Good evening, sir. Okay, sir. Thank you. Good evening, everyone.
Good evening, ma'am.
Good evening, ma'am. So, shall we start?
Yes, ma'am.
Yeah. Yes, Suchitra, ma'am. Good evening. Fine. So, I think we ended the session yesterday on packages, right?
Yes, ma'am.
Yes. So that means from there I'm starting, and today's agenda is I'm going to discuss the probability distributions, right? So I'll share my screen. I hope screen is visible.
Yes, ma'am.
Fine. Thank you, ma'am. So, friends, now we will talk about the distributions. That is probability distribution, right? So, when we say probability distribution, firstly, anyone who can tell me what is probability?
The chance of occurrence.
Yes, very correct. The chance of occurring or happening of any event is known as probability, right? And I think when we say probability, even in the day-to-day basis, if I say we're using probability very occasionally, generally we will say probably the person will arrive, something like that. So that means probability generally directly or knowingly or unknowingly we are using in our day-to-day life also, right? So next term comes probability distribution. What is this probability distribution? Anyone who can tell me what do you mean by frequency distribution? Yes. What is the frequency distribution? Anyone? Yes. No idea. What is frequency distribution? Anyone?
Hello, I think, ma'am, it's our data is not distributed or not, and our about mean if we have collected data, so we want to check if our data is normally distributed or not, like this.
Okay. So for the purpose, are we using the probability frequency distribution? Is it? Okay. Okay, fine. I think some of the words I have not heard. I think, ma'am, maybe there is some problem network issue at your end, probably. So I'm not getting you clearly. But I think when we say frequency distribution, it is a distribution of the frequencies of the observations, right? That means when there are repetitions, so rather than writing the repetitions, we will write the observation once, and then against it we are writing its frequency. That this type of arrangement is known as frequency distribution, right? Similarly, when say probability distribution is what it is a distribution of probabilities. distribution of probabilities of all the outcomes of any event, right? So whatever is the event, whatever number of possible outcomes, for that for those outcomes, whatever is the probabilities, the distribution of them is known as the probability distribution. Is it okay?
Yes, ma'am.
Okay. I think possible word is more relevant here, so I have written here all the possible outcomes of any event. Right. Anyone who has idea the type of distribution?
Yes, ma'am. Normal distribution, binomial, and Poisson.
Very correct. So when we say type of distribution, broadly we can classify the distribution into the two parts, that is discrete and
Continuous.
continuous. Very correct. So anyone is having the idea what is the discrete probability distribution?
Yes, ma'am. Poisson and binomial discrete, and continuous is normal distribution.
Okay, these are the names of the distributions. Very correct, ma'am. Okay, anyone is having the idea what is the discrete probability distribution?
Where there is frequency given the whole number.
Sorry? I didn't get. I don't know who said. I didn't get, ma'am. Will you please repeat? Yes.
Those variables which are countable.
Okay, fine. Vibhuni, ma'am. Okay. Anyone else? Frequency is given in the whole number. Kavita ma'am has written in the chat. Means I need to switch the screen when I need to read your comments. Okay, fine. So when we say discrete probability distribution, here discrete meaning is when the nature of the event is discrete or the outcome which are coming from the event are discrete in nature. So when we are having the events and their outcomes in the discrete nature, and when we are studying their probability distribution, then it is known as discrete probability distribution. Is it clear?
Yes, ma'am.
Any example?
Like number of error in a typed page, number of accident on a particular road.
Very good. Number of accidents occurred on a particular road in last 1 hour. You can say this thing, right? Or maybe the number of, as ma'am said, mistakes on a particular page, right? Or number of students taking admission in particular year in a particular organization. So that way you can see this is where the event outcome is nature is discrete, right? So this is known as discrete probability distribution. Again, as ma'am said, there are two types of discrete probability distribution, that is binomial and Poisson. But it is not like only these two types are there. There are some more types are available, like uniform probability distribution is also there, which is coming under the discrete probability distribution, right? So when I say binomial and Poisson, so these two are the discrete probability distribution, because here the nature of the event or the outcomes which are generated by any event will be discrete in nature, right? So when I say binomial probability distribution, so binomial probability distribution is what? When first thing is a discrete probability distribution. Second thing, any outcome, or any event which has two discrete outcomes can be considered or studied in binomial probability distribution. So I think many of you are having the good idea about the distributions because people are interacting when I'm asking few things. So when we say the two outcomes, so generally we know this thing, the two outcomes are generally what I can say named as the success and the failure. Success and the failure, these are the two names we are giving to the events, right? Say for example, if I am tossing a coin and expecting a head, so the success will be coming of it. And if suppose coin has turned as a tail, that means that will be the failure. Is it clear?
Yes, ma'am.
Okay. I hope clear to all.
Yes, ma'am.
Fine. So that way it is known as binomial probability distribution. Second thing is there are two parameters. That is N and P. N is what?
Number of trial.
Very correct. Number of trials. P is
Of getting
probability of
success.
success. Very correct. Right. Then the mean of binomial distribution is generally represented by N into P. N is standard deviation is square root of N P Q. What is this Q?
Probability of failure.
Very good. Q is
1 minus
probability
P.
of failure. Yeah, very good. Very good. I think you people are having a good idea about the distributions, right? So this is the basic thing about the binomial distribution, right? Talking about, I think we know manually how to calculate binomial distribution probability. It is NCR, P to the power R, Q to the power N minus R, right? When we talk about the next distribution, I think one more thing is here. Generally, when we talk about binomial distribution, here the size of sample will be smaller and probability will be higher comparatively. Comparatively of what? In comparison to what? In comparison to Poisson distribution, right? So next one is the Poisson distribution. So again, it is a discrete probability distribution. Right? Then generally here, when we are expecting a discrete outcome or the nature of outcome should be discrete, also there is one more thing, that is that particular event or that particular outcome should occur on a particular period of time or in a particular period of time, right? So here the event is expected to occur in a specific period of time, right? So this way it is different from the binomial. Then here size of sample or trial is large and P, that is probability, is smaller. So this is the, what I can say, the one limitation of the binomial distribution when the size of sample is very large and That means in that case we cannot go for the binomial distribution calculation. So that is why we are having the next distribution available, that is Poisson distribution. And to limit this sample size, generally we are saying that the particular event will be occurring in a particular specific time period, right? So the parameter here is mean, generally represented by lambda. Till here it is fine.
Yes, ma'am.
It should. I have made a change if somebody is noting it down. M is equals to NP. I think in hurry I have written N is equals to NP. M, that is mean. Mean is equals to N into P. Fine. Now, next is the continuous. What is continuous probability distribution?
Distribution.
Yes. When the occurred event is continuous in nature, there we are talking about the continuous probability distribution. So in that case, for that type of event, you will looking that just for that type of event, we are looking what are the probabilities of occurring of those events. Is it okay?
Yes, ma'am.
So as I said, generally or broadly in continuous probability distributions, normal probability distribution is very much popular. And I think yesterday, I guess, I think I said something about the curve and all. Yesterday only I discussed, right?
Units and all.
Yes, yesterday only I discussed about that, or normal distribution I discussed in the context of the normality of the data, right? So when we say continuous probability distribution, generally the one distribution is coming in our mind is normal probability distribution, right? So here, whatever events we are studying, all the events will having the outcomes in the form of continuous variable, right? So when these type of outcomes are coming which are continuous in nature, we are talking about normal probability distribution. Further, there are so many different what I can say the characteristics available of the normal probability distribution. But from the point of view of the probability distribution, I think I'm not talking about those. Further, when we are starting with the statistical test, then I think we will discuss those characteristics and then we'll see how we can check those characteristics here in the R environment, right? So here I'll talk about the what I can say. Yeah, generally it is represented by bell-shaped curve, right? And we are assuming that area under the curve will be how much?
1. M1.
1. Very correct. And mean lies at the middle of the curve. Yes.
Yes, ma'am.
And the expectation is that mean will be equals to median and it will
Median
be
and mode.
mode. Generally, these are some of the very basic things about the normal probability distribution, right? Now, when we say R programming, right? Give me a second. So when we say R programming, here there are various functions available. Using that, we can get the probabilities of these things, right? And also when the data size is very large, for that data size, if you want to plot or you want to see whether the data is normally distributed or not, you can plot them on a graph also and you can check the normality also, right? So here we will talk about now some of the functions which can help us to find binomial Poisson and the normal probability distribution or the normal probabilities of the outcomes of the particular event, right? So I'm writing certain functions here. Firstly, for the binomial probability distribution. Here we can say p-binom is a function. Generally, this function we are using to get the probability indivisible or exact outcome, right? The syntax says p-binom, in brackets, it is asking you the x, that is your vector or your variable, and then you need to give the size of, and then you need to give the probability of success. Generally, these are the three parameters which you need to pass to get the p-binom, that is a probability of the exact or the indivisible event, right? Next function is in this category is the p-binom. P-binom we are using to get the cumulative probability. Cumulative probability meaning is what? Anyone?
Madam, when we club the probability of existing event with the next one.
Yes, very good. When we say cumulative probability, that means we are looking the probabilities more than one outcome, right? So you will add all the probabilities. Suppose I'm looking the probabilities of 2, 3, and 4. So by adding them, I'll get the cumulative probability, right? So p-binom is asking you to provide the x. It is asking you to provide the size, that is n. I think n is much easier to understand, and I'm writing. And then it is asking you to give p. And also there is one important, that is lower dot tail. So the output, or sorry, so lower dot tail will be, I'll tell you what is the meaning once we will do a few problems on this. We'll see what is this lower dot tail. Generally, this particular parameter is logical parameter. Here you need to write true or false, right? Next is the q-binom. Q-binom is the quantile binom, right? So it is means it is giving you, rather than getting the value of the probability of the outcome, here you need to pass the probability. It will give you the value of the x, right? This is requiring p, n, and the probability of the success, right? And sorry, p, n, and it is asking you the lower dot tail, which is again a kind of logical parameter, right? So here you can write returns the value of quantile. Quantile means variable. Next, R binom. R binom is the function which we are using for generating the random numbers which follows the normal distribution, right? So it is asking you how many numbers you want. You need to define the size, you need to define the probability. So this is known as the four functions. Using these functions, we can get the probabilities. One of them, that is q-binom, will returning the value of x when you are providing the value of the p, right? So this way, these functions we are using in case of binomial probability distribution. In case of Poisson probability distribution, again we will be having the four functions. So here I am writing it's P, no, it's poise. PP poise, yeah. I think this is the function, right? Yeah. It is asking you for providing the, I am writing P. So you can see I have written this. If you are not able to recall what you need to pass, so using this question mark, you can take a help also, and this window is showing you all these, right? So here I am writing all the 4 depoys, which is asking you to provide X value and the lambda, that is the mean value, right? Then P poise is what? It is giving you the, again, what? Just a minute. It is so when we say just a minute. When we say P poise, so it is giving you the cumulative probability, means meaning will be all same, which I discussed in case of the binomial distribution. Only the function name will change, right? So P poise is asking you X lambda, that is the mean value, and the lower dot tail, again, which is a kind of logical parameter. Then we are using the Q poise. Q poise is asking you to provide you the P value and the lower dot tail, which is again a logical. And I think lambda also, I forgot. Yes, lambda is also there. Just done it. It is lambda, right? And then lastly, the R poise. R poise will do or will generate the n random numbers which are following the Poisson distribution, and the distribution will be having that particular mean value. Lambda is the mean of the Poisson distribution, right? Next is the normal probability distribution. So here we were using the D norm. Yeah, I'm correct. It's D norm only. So D norm is asking you to provide X mean standard deviation and log. So you can write X, the mean, the standard deviation, and only 3, means these are the must parameters which you need to pass to get the probability of the any individual event or the exact event, right? Whereas when we talk about the P norm is asking you the value of X, then mean, then ST, and then lower dot tail. Right? By default, you can see lower dot tail is by default true. You can find logical, means lower dot tail is a logical parameter and it is by default true. Right? So if you want to make it false, you need to define and write F. Fine, everyone?
Yes, ma'am.
Fine. Next is the Q norm. So Q norm is asking you again a different opposite thing. It is asking you the probability value, the mean value, the standard deviation value, and lower dot tail. These are the some parameters which you need to pass. And the last one is R norm. R norm is generating the random numbers which is following the normal distribution and will be having the mean and standard deviation which you are specifying there. So these are the some of the functions. Using that we can get the various probabilities of these different probability distributions. Is it okay, clear to all?
Yes, ma'am.
Fine. Now, suppose I'm having a very simple problem. If a coin is tossed 4 times, then find the probability of getting, suppose, 1 head. So, firstly, you need to identify, if I have written this problem, this will be coming for which particular distribution?
Binomial.
Binomial. Why?
There are two chances of occurrence, head and tail.
Very correct. So, first thing, it is a discrete kind of outcome, right? 1 head I'm looking for, it is not like 1.5 head I said, right? I'm looking for 1 head, exact value, right? So it is a discrete outcome. Second, there are only 2 possibilities, whether head will occur or it will not occur, right? Clear? Fine. So, okay, apart from this, as you have identified here, we will go for the binomial distribution. So there are 4 functions I have shown. Can anyone tell me which is the appropriate functions or function which I need to use here to get the probability value?
DBI norm?
Sorry?
DBI norm?
D-binom.
Yeah.
Very correct. So if we are using the D-binom, just a minute, I'm copying this. So according to the syntax, anyone who can tell me what will be the value of X?
Is it 4?
Is it 4? Okay. Okay, then size will be?
Sorry, 1
Hmm.
and size will be 4.
Very correct. And probability value will be?
Point half, 0.5.
0.5. Very correct. So when I'm using D-binom, I am passing 1, 4, 0.5. Probability is 0.25. Fine.
Yes.
Similarly, in the same situation, if I'm looking for probability of getting, suppose, at least 2 heads. Anyone?
In this either we can individually calculate the value for 0, 1, and 2. Sorry, at least that means 2, 3, and 4. 2, 3, and 4.
Okay, so it means X will be?
X will be 2, 3, and 4.
Good. Okay.
and the size will be 4.
4 only, yes, correct.
Probability will remain 0.5.
Good.
Or what we can do is we can calculate the 1 minus cumulative up to 2.
Okay. That is also possible. So, okay. I think, I don't know who was interacting.
Yeah, ma'am, Vivek.
Vivek sir, fine. So, okay, fine. I think Vivek sir has said correctly. Anyone is having any other idea? Or which function I need to use here? I think it is when we are looking for 2, 3, 4, that means it's a kind of cumulative probability, right? So which function I will use here?
P binom.
P binom. Very correct. Fine. In the P binom, we need to provide X. X will be what?
Ma'am, 1.
1. Okay, fine. Then 4. Then 0.5. It is fine? Or anything else I need to write? Yes.
We also need to talk about the lower tail.
Yes. Fine. So what I need to write?
Lower tail is equals to 0.
Okay. Is it fine? Yes. Anyone? Yes.
It will calculate from 0 to 1. The cumulative value from 0 to 1.
Okay. I think, Vivek sir, you said this syntax right now. I think you was interacting with me.
The last part, that is lower tail.
Okay, you said this, right?
Yeah.
Yeah, I think it's correct. Okay, how many of you have understood what it will do for us or what it is doing for us? Anyone? I said, I think we know the syntax. I have written up little up. This was the syntax, right? I said this will take either false or true. By default, it is true. And meaning of true is what? You can see here, by default, this lower dot tail is true. And true meaning is it is less than equals to. Right? That means whatever I mentioned is the position number 1. Right? If I'm making it or if I'm not passing anything at the 4th position, it will take it as up to 1. That is, it will give you the probability of 0 and 1 because P binom will give you the cumulative probability. But when I have made 0 at the last position, when I have entered 0 at the last position, it has converted to greater than. So now it will give me the probability of greater than 1 and it will accumulate. So we are having only remaining 3 outcomes, that is 2, 3 and 4. So it will combine the probability of the remaining 3. Is it clear?
Okay.
Yes, ma'am.
Okay. Other way around, if you want to get the same thing, you can go with this only. this also P binum in brackets 1, 4, 0.5. This will also work. Or D binum 2, 4, 0.5 plus D binum 3, 4, 0.5 plus D binum 4, 0.5. These are the three different ways of getting the solution of this one problem. Clear?
Okay.
Is it fine?
Yes.
Suppose the last I'm taking here in the P and D binum at max 2 heads. Okay. I hope you people have thought on this. Any idea?
Either we can calculate 0, 1, 2, D norm,
Yes. Yes.
or we can calculate the cumulative up to 2.
Yes. Very correct. So means here your x will be 0, 1, 2, right?
Yeah.
Size probability will remain same.
Yeah, 0.5.
As sir said, I'm copying this to save our time. Done? Fine. Second, using P binum. What I need to write? Done?
Yes.
I think only Vivek sir is speaking. What about others? Okay.
Yes, ma'am.
Okay, Anup sir. I think Sairaj sir, Anup sir is also active. Fine. So means it is clear. P binum by D binum is very simple, right?
Yes, ma'am.
Fine. Now, if I talk about the next, that is the, suppose I want to generate ten numbers following binomial probability distribution. So we will use R binum, right? Suppose size I am taking 100 and probability I am taking suppose 0.5. Right? So these numbers together will follow the binomial probability distribution. Done?
Yes, ma'am.
So again, if you will, what I can say, run this every time because it's a random generation. So every time, as many time as you will run the same line, every time you will get the different numbers. Fine.
Yes, ma'am.
Next, coming for Python. I think I need to see any. Just a minute. Give me a second. I'll take some problems. I have already written few problems. I think these will be, but I need to see specifically for the poison. Give me a minute. I need to read it. Okay. You can read the problem I have written or copied from one of these other source. You please read the problem. Done reading?
Yes, ma'am.
Okay, so after reading, can you tell me which function we will use first? Yes. Anyone? Okay. No idea?
P-poise.
P-poise, very correct. So can you tell me, sir, what is X here and what is lambda value here? Yes.
Lambda will be 12 by 60.
Lambda will be what?
12 by 60.
12 by 60. Why so, sir?
Because it says 12 cars crossing a bridge per minute.
Okay.
Or sorry, it will be 12.
It will be 12. Very
Yeah.
correct. And X will be?
X will be 17 or more. That means greater than or equals to 17.
Right? Fine.
Yes.
It is suffice. Sorry, it is suffice. Yes, is it okay? Or not, anything else I need to write? Sorry?
17 or 16?
It will be 17 or 16. That you need to tell me. That is what I'm asking you. Yes. Yes. It is fine now. Yes.
Yes. Yes, I believe so.
Yes. It is, I think we have reached or we have got the solution. Fine.
Yes, ma'am.
Okay. Suppose same problem. Now we are looking the probability of exact 17 cars crossing the bridge. In that case,
Then we will use depoise
okay, and syntax will be
x lambda. So that means 17, comma lambda. Lambda will be 12.
Right? For exact 17 cars passing the bridge. And if it is suppose less than 18 cars, then
Then we will use cupoise.
cupoise. Okay. I think I'm asking less than 18 cars passing the bridge, then what is the probability? I haven't asked you if this is the probability, what number of cars is passing from the bridge. Right? So cupoise will be used when we want to get the number.
Okay, so again, then we'll use p-poise then.
P-poise, yes. Whenever it is a case of less than, more than, exact, means at max or at least. So in that case, we are using p-poise or p-binom or p-norm because it's cumulative, right? So what will be the syntax now?
I'm 17.
17, okay. Then
12. 12.
12. Anything else?
We need to talk about the lower tail.
Okay, so what I need to define? 0, 1.
One.
Okay. 1 means true. This time I'm writing T also so that you can understand T is also true, right? Or 1. So if, just a minute. So if even we are not defining the 1, even that will get the same answer because by default it's true. Right?
Okay.
Okay, I think today the male participants, male friends are interacting. What about the females? I think people are listening only, performing also. Yes. Soumya ma'am.
Ma'am, today I feel like I'm out of the box here.
That
It's
is
been so
why
long. Actually, it's been so long that I left all these poison distribution and all, and you're upfrontly running as such. I feel like, I mean, that is my feeling. So I feel out of the box. I'm in the wrong window.
Oh God. I think it is not good for me if you are
But
saying.
no, ma'am. But I'm noting it down so that I can practice at a slower pace.
Okay, fine. What about other participants? Monica ma'am, Rinal ma'am, Samira ma'am. I hope you people are performing or maybe noting it down. Yes? Yes or no?
Yes, ma'am.
Very, very, very low tone. What happened, ma'am?
It's a weaker yes.
Yes, seriously. Just a minute, I am doing one thing. I am copying and pasting the syntaxes in the chat. Is it fine? Probably it will work. Yes? Yes or no? Okay, Piramal sir, okay. I have read. Okay, I think sir you are writing in the chat. Thing is that I think I told you previously also because once I'll be on a different window, I cannot see what people are writing in a chat. So it's a humble request if you can unmute yourself and can interact. Do I need to again explain you the lower tail concept? I think all the syntaxes for D binum I have pasted in the chat. If you wish, you can copy from there. Now I'm doing it for the Poisson.
Sure, ma'am.
Yeah. So for Poisson also, what we did till now, I have copied and pasted in the chat. So if you wish, you can copy and paste and in a Word file or somewhere you can keep it, or maybe even you can copy and paste it on your R script also. And one by one you can run. Almost the question is also written there, and the solution is also there. So this way you can go. Is it okay? Yes.
Yes, ma'am.
Fine. So, Piramal sir, it is my request. You can also copy and paste, and please tell me. Still, do I need to discuss the concept of lower tail, or it is clear now? I hope you are listening to me, Piramal sir. You can put a message. I am on a chat window right now. I can read if you are writing something. Okay, again, sir has written fine. So, sir, I'll take one problem for the normal distribution. And by discussing that problem, I'll tell you the concept of lower tail. Is it fine? Piramal sir, I hope you're listening. Is it fine if I take an example? And taking an example, if I'll explain you, I think that will help you to relate more. Yes, fine. So I'm just, give me a second. I'm just taking some examples. from the okay. I'm copying and pasting some of the problems so that we can solve all of them and you can make it clear that what is these concepts. Fine. Give me a second. I'm copying the problem in the chat also, right? So this way you will also be having these problems with you. So you can take it these problems from the chat. So I have copied down the problems in the chat, right? So now you will also be having the same problems which I am solving here. Fine. I hope visible to everyone in the chat.
Yes.
Fine. So now again I'm sharing my screen and then we will start discussing these problems and trying to resolve the problem of Piramal sir. Okay. I think my window is visible to every one of you.
Yes, ma'am.
Fine. Here I am talking now about the normal distribution. Fine. So here you can see the problem I have written. X is normally distributed variable with the mean of 30 and the standard deviation of 4. We need to find the probability when X is less than 40. Fine.
Yes, ma'am.
So you need to firstly identify here which particular function we are going to use. The functions are, I think you are knowing now, the D norm, P norm, Q norm, and the R norm. These are the 4 functions. You need to tell me which is the most appropriate one here.
P norm.
P norm, very correct. Because I just said when there is a case of less than, more than, less than equal to, more than equal to, or at least at a max, etc. In that case, we are using the P norm or the P, that is cumulative function, right? Cumulative one we need to use. So it is very appropriate. We are going to use the P norm. So this function is requiring what? P norm needs X, mean, SD, and lower dot tail. Lower dot tail is the optional parameter, right? So now you need to tell me, I think X is already given here in the question. X should be less than 40, right? Mean is also given. Mean is what? It is 30.
30.
And SD is what?
4.
It is 4. Fine. So you need to only see if all the things are available, you need to only decide upon the lower dot tail. So now Piramal sir, if you are in the meeting, you need to listen now. Because when I talk about the lower dot tail, so you can see, just a minute, I'm coming to the normal distribution. I think this is normal. Yeah. You can see my 4th window. I hope visible to you, right? And then when I'm talking about this lower dot tail, all the arguments which we are passing inside these functions are written here, right? So as I'm talking about the lower dot tail, so you need to see lower dot tail is this. I am selecting this. You need to carefully read. Firstly, lower dot tail written here is logical, means this parameter or this argument is the logical argument. Logical meaning is when you are passing this argument, you need to give either the false or the true. That is the 1 or the 0. False is 0, true is 1. So that you need to pass if you are passing this particular parameter or argument, right? Further, it has written if true means by default true, right? So if you are not giving lower dot tail inside the P dot norm, that means R will understand that by default it is true. And the meaning of true is what? That the probability is less than or equals to. right? So less than or equals to meaning is what? Whatever you are mentioning at the first position, that is X. So here, if suppose you are mentioning the 40, suppose I am writing P norm, and if I am mentioning 40, passing the mean 30, standard deviation was 4, I guess, right? And I have written, suppose here, nothing. So meaning is what? If I have passed nothing here, that means at the fourth position or the fourth argument I have not given. So that means by default it will be true. So true meaning is what? Whatever I am passing at the first position, it will return me the probability of less than equals to 40. Clear?
Yes.
Yeah. Now, question comes whether we want or we are looking for the less than or equal to. No, we are looking for the less than 40. Right? Is it clear? So that means here I need to pass 39. I hope it is clear. And if again you are not passing anything at the fourth position, no argument, that means by default it is true. So it will return me the probability of less than or equals to 39, means up to 39. This particular function will return me the probability. That means starting from 0 to 39. It will accumulate all the possible, whatever the possible outcomes are there. So from 0 to 39, it will add them and return me the probability 0, 1, 2, 3, 4, 5, 6 up to 39. Is it clear now? I think someone please see in the chat if sir is written something. It is yes? Yeah, fine. Thank you so much. So this way you can see now I'm executing this. This is the value we are getting. Done? Is it fine?
Yes, ma'am.
Suppose I'm giving you, as I'm not having any other problem here, but still I'm creating one more problem for you. I'm writing here P is X, P of X less than or equals to 42. So now this is your call. You need to tell me what will be the syntax. I think when it is less than equals to, you are knowing which function you need to use. It is cumulative, right? So you will use P norm. This is clear to everyone, I think now. Now you need to tell me what will be the syntax.
Uh, 42,
Mhm.
30, and 4.
Mhm. Done, sir? Vivek, sir, I think, right?
Yes, ma'am.
Yeah. So I think it is correct because at the fourth position, fourth parameter argument, I have not given. That means it is returning me the probability less than equals to 42 because by default it is true. So this is correct, right? Now, suppose situation is P of X. You are writing greater than and equals to 42. Now,
We can use 1 minus
hmm,
P norm
okay.
41, 34.
Okay. It is fine, everyone? It is fine, everyone? Done?
Yes, ma'am.
So 2 ways, I think one is communicated by Vivek sir, second I tried. So shall we proceed for the next problem now?
Yes, ma'am.
Yeah. So next is this. I think everyone is having the same problem. I have already copied in the chat. You need to read the problem and then we'll proceed. Reading done? Okay. Talking about the first problem. Right? What percent of the people earn less than 40,000? So firstly, X will be what? This. Fine. Mean will be what?
50,000. Standard deviation 20,000.
Very correct. So I think problem is in front of you. Now you have to tell me. I think P norm we are using because it is assumption is that the salary is normally distributed. So we are using the P norm, right? Then
40,000.
40,000. Okay. Is it correct? Is it correct?
Yes, ma'am.
Rather than passing 40,000, can we pass 39,333 4 times 9? Is it fine?
Yeah, we can do that.
Because it is less than 40,000, right? Is it making sense or not?
Yes, ma'am.
Just a minute. I think number of employees are not mentioned here, right? Right, fine. Suppose I'm entering. This is returning me the probability, but you can read the question. It is asking you the what percent of the people earn. So that means probability is this. Answer will be what will be the answer? Almost 30 point.
Multiply with 100.
Yeah, 85% people employees. Right. This will be the answer.
Yes.
Fine. Second problem. X will be
25,000.
greater than or equals 25,000. Now please solve this.
We'll use PNOM as PNOM 25,000.
Hmm?
50,000, 20,000,
Hmm?
and then comma
It's a case of more than. You can see the syntax. In case of more than what we are using. True, it is true by
false.
default, it is right. So we'll use false.
Yeah, 0.
But it is correct. Can we make it this? Yes. Because once we are making it false, that means it is giving you the probability of the number greater than this, and we want to include 25,000 there. It is greater than or equals to. Getting me?
Yes, ma'am.
So the answer will be 89.44%. Employees or people are getting the salary greater than or equals to rupees 25,000. Is it okay?
Yes.
Fine. So next, if suppose I want to generate random numbers, right, which is following the normal distribution. So suppose I'm coming here and writing R norm. So I need to provide how many numbers I want to generate. Suppose I want to generate 20 numbers. The mean of the distribution will be suppose 5, and the standard deviation will be should be suppose 1.25. Visible? So this way we can generate the random numbers which are following the normal distribution. Is it clear? There's a pin drop silence. What happened? Yes. Is it fine, friends?
Yes, ma'am.
Yes, ma'am.
Is there something that it means it was very technical today? It is something like that? Means statistically it was technical, I think. Syntaxes are very easy today, right?
Yes, ma'am.
Okay. So, so can we keep it till here only?
Yes, ma'am.
Okay. So just I need to check if I'll having certain exercises I'll provide you, and you people can do a practice for the same, right? So that way it will be easier for you to understand the things. I think I'm copying the problems in the chat. If you can copy from there in your sheet, worksheet, workbook, wherever it will be easier for you to get the problems, right? I hope problems are visible.
Yes, ma'am.
Yes, ma'am.
Fine, you can copy and paste somewhere in your files. I think 3 problems are enough for you to practice. You can do the practice. You need to firstly read the problem carefully, need to identify which distribution you are going to use, and then you can decide which function you need to apply to get the solution of these problems. Is it fine?
Yes, ma'am.
Fine. So I think before ending, I need to tell you something. Tomorrow, I think it will be little difficult for me to take a session as I'm having a meeting at my college around 5. It will start and maybe it will take time in ending the meeting because it's related to the international conference in our institute, right? And then probably I'll get free probably by 7:30. But the thing is that after that I need to go in a marriage. It will be difficult for me to take session tomorrow. So will it be feasible for you if we can arrange the session on Sunday in the evening hours?
Yes, ma'am.
Okay. What about others?
Ma'am, we already have a session on Sunday, right?
No.
Okay. So
Right.
fine, ma'am.
So can we keep it on Sunday evening?
Okay, ma'am.
Fine. So I think 2 people are saying
Ma'am,
fine.
time.
Around same time,
Fine,
5:30.
ma'am.
Okay, ma'am.
Shivangi ma'am, it is fine for you?
Yes, ma'am. Ma'am, I have one request.
Yes.
Actually, I'm when the session is running, actually I'm traveling. That's why I work after your session.
Okay.
Okay, ma'am. So please provide me the questions. Uh,
Okay. Means the problems you are asking me,
yes, ma'am.
which
Yes.
I discussed previously.
Yes, ma'am.
Okay. So ma'am, I'll do one thing. Or if you people can wait in the session, can I provide here only in the chat? Will it be fine?
Yeah, alright, ma'am.
Sorry.
You can WhatsApp the problems.
Okay. I need to check. I think I will be there in a WhatsApp group. I'll check. And if I'll be there, I'll provide you there, right?
Okay,
Fine, ma'am.
okay, thank you, ma'am.
Okay. Thank you. So I think I'm
Hello, Chandana madam.
yes, sir.
Hello, madam. It's
Yes, yes, sir.
Parimal sir, madam.
Yes,
I'm
yes, yes,
sorry
sir.
for interruption. Like actually, I also ma'am actually travel like a lot. Like actually, after the five actually 5:30, I
Okay.
used to travel 2.5 hours.
Okay.
I used to travel to my home by 2.5 hours ma'am actually. So that's why I could not able to like talk. So, but I am attending your sessions over like my mobile and all. Or I'm always try to take the screenshot also. I mean, it will be very nice if you can provide this particular the course whichever has been happened so far 3 days in a WhatsApp, ma'am.
I'll do one thing. I'll
So it will be very
copy
nice, ma'am.
whatever I discussed on the R script. I'll copy that and paste in the chat. Sorry, in the Word file, and I'll share that. Is it fine?
Sure, ma'am. And also, ma'am, for the sessions, for the homeworks, the assignments you have provided, kindly, ma'am, provide the
Yes, that I promised
answers of
you,
that
ma'am.
also, ma'am, in WhatsApp, ma'am.
Answers. Okay, okay, okay. I'll try to solve the questions and I'll provide you. Fine.
Okay, ma'am. Thank you very much, ma'am.
Thank you so much, sir. And I think I extremely sorry. I was reading it Piramal. It's Parimal. Sorry. Thanks.
It's okay, ma'am. No problem, ma'am.
Yeah.
Thank you, ma'am.
Fine. Thank you so much, sir. So I think it is all from my side, friends, right? We are meeting now on Sunday. Tomorrow will be the no session, right? So I think I informed you. So accordingly, you can plan whatever you are having your plans tomorrow. You can do that. We are meeting on Sunday around 5:30. Fine, everyone?
Yes, ma'am.
Thank you. So, Yoga sir, I think we are done for the day. I think Yoga sir asked us only, Anna, that we are planning the session on now Sunday. 5:30 same time. Thank you so much, sir. Thank you.